Hello everyone, today we're going to talk about very important topics. Chapter 5.2, Operations on Vectors. Okay, Section 1, Additions. Okay. 5.2, Operations on Vectors. Okay. Section A. Additions. We're going to talk about this additions, okay? So, okay, if an object is translate from A to B and then from B to C, the combined effort is a translation from A to C. Okay, let's draw diagram to show these things. Okay, so for example, okay, for example, we have a line from A to B. Okay, this direction, and then from A to B and B to C. B to C, okay? So we can see that the combined efforts of these translations from point A to B and then B to C is combined. The combined efforts is translation from the A to C. Let's draw a line from A to C. Okay. Okay, so from here we can form a triangle. So from point A to B and then from B to C. Okay, then from here we have a combined effort is translation from A to B. So from here we can see this combined effort is addition of vectors A, B and the BC. This is the combined effort, then become equals to A to C, means AB plus BC equals to AC. Okay, so it's the same thing like this. So okay, for instance, okay, so we have a location A. From A we comes to B. Then from B we come to C, but in terms of the combined efforts, actually from point A to C, right? So from here we can see that. So a point and object, so is translated from A to B. Then after that, and then translate from B to C. So this combined effort is translation from A to C, right? Okay, from A to C. Because we move to here and go to here, right? So that's something we're talking about. So and then from here we can see that, okay, so then we can see this combined effort. So from here we can know this AB plus BC equals to AC, right? So from here, okay. So this AC we give a name called, the name is the sum or sometimes we call or we call that is the resultant of a vector of the vector AB and the BC. So we call the sum of these two vectors. So basically, it's the AB plus BC equals to AC. So from here, so basically these rules, we also can come up with rules of this AB plus BC. We call it, we give a name, very important name. We give a name, call it, because this is a triangle. This is a triangle, so we call it triangle. So we give a name, triangle law of vectors addition. Okay, so then we have this law. Okay, so in this law, so we have this terms. We have AB plus BC equals to AC. Okay, so here we know that, okay, A is initial point. A is the initial point, right? Initial point. A is the initial point, or the starting point. A is the starting point. So we call that B. B is intermediate point, or we call it middle point. Okay, so both B we call it intermediate point, or you can call it middle point. And then C is our ending point, or we call it terminal point. So once we combine these two vectors together, our starting point, or ending point, we can see that in between, anything in between is the middle point, intermediate point. So once we have moving here to here, or we're moving here to here, so we will get a final result, the same result, A to C. So from here we see that the A is the initial point, and the B is the terminal point. We add up the two final points together, so we'll get this law. The law calls triangle law, because this form a triangle, right? Okay, so let's try another one. So can we have a different triangle? So whichever points in between A to C will have this triangle law. Let's draw another triangle. Okay. So for example, from A point, we are moving another intermediate point. We call it maybe M, right? And after from M, so after the object from A initial point move to another point M, so the M is going to continue to translate to the point C. So, okay, for example, we have this. So we also can see that, okay, we also can see that the AM plus M plus MC also equals to AC. So any points in between, let's say from B or M, they are all of them are the intermediate point. This is intermediate point. They are all fulfill the triangle law. Even we draw another one. Even we draw another one from here, comes to here, they all fulfill because they are all the starting point and ending point are same. So this is a very important concept. Any point in between, this M can move to here, can move to here, you just move to here, coming up, they all fulfill the triangle law of the vector additions. Right? Okay, so this is very clear. Okay, let's move on to another important concept. Okay. Okay, I'm gonna remove this. So the first important concept we talk about is the triangle law of the vector addition, right? Actually additions. So now we talk about another concept. Okay, so before that, let's draw a diagram. So we have a two vector, okay, AB and AD. Okay. AB and AD. Okay, they all have a common initial point. Okay, now let's draw a parallelogram. Okay. Okay, let's assume this is D. So now we have a point in this parallelogram. So we have a point C. Okay. Okay. So let me join up this A and C. So we join up this A to C. So from here we can see that, okay. So from here we can see, okay, an important concept that is, okay, in this parallelogram, okay, A, B, C, D. Okay, so we will have a very important concept is that, okay, so because in these parallelograms, these two lines, AD is parallel to BC. Okay, AD is parallel to the BC. Okay, and they are the same. They are parallel. They are in the same direction. Also, they are also N A D equals to BC. Okay, in terms of the distance, or we call it magnitude. Okay, because these two are equal. Okay, so then we can come out. Okay, A D equals to B C, right? So they are the same direction, they are the same magnitude. So we find out these two vectors are same. Okay, so since let's put up together. Okay, second things. Okay, AB plus AD equals to AB plus, because we already find out this, right? So from here we can change to BC. Okay, now we know very important concepts, because we already learned just now. Okay, if A is the initial point and C is the ending point, so A and B is the intermediate point. So then we can have this triangle law. We have this triangle law, so we can apply in this triangle. So we can find out equals to AC in the triangle of ABC, right? So we immediately find out, because these two lines are same. So we from here and we come up, so we will know these two vectors add up become this. So that is very clear, right? So therefore we know AB plus AD equals to AC. Okay, so that is very interesting, right? Okay, now we have another important law of vector additions. So we call it parallelogram law. Parallelogram law of vector addition. Okay, so in a parallelogram ABCD. Okay, for example, so ABCD. So we will have AB plus AD. So then equals to AC. So this AC is also a diagonal. Is the diagonal of this parallelogram. Okay, so we'll have this important law. So here, let me just fill up here. So we learn two important law: parallelogram law of vector additions. Okay, important, right? Here plus here equals to the diagonals. Okay, now we move on to the example. Example 7. Let's make an example. So we have example, okay? Example 7. Okay, so in the diagram we have these four things, and then we have to do okay, for example, okay, now we have these diagrams. Okay, let's look at this diagram. Okay, so we have in these diagrams, each of the vectors has been expressed in A, B, C. Okay, so we have this diagram. So let's look at first questions A. Okay, so for A plus B, we find the sum of A plus B from this vector to the A. We move this point to here, then become B, right? Okay, now let's add up these 2 points. These 2 points we call it A plus B, right? Okay, let's do the calculation. So we translate. So basically, the step 1 is translate a vector B to the B's initial point to the vector A's terminal point to the vector A. So translate A's initial point to the B's terminal point. Okay, so from here we can see that we add up these two together. So basically, this is A's ending point, this is the B's initial point, just move down to here, right? And then we get this A plus B. So how we calculate the A plus B? So now the second one is, okay, so this is in the X component. One unit to the right. Okay, and the Y component is downwards, right? So how many unit downwards is 5. It's a 5 unit. The 5 unit downward. Okay, so in this case, so then we can find out in the column vector A plus B equals to, because this is going right, so it's -1, and going downwards is -5. So then we can find out these vectors. We can use the column vector to describe in this way, right? So this is the first question. Okay. B is B plus C. Okay. So now we see B plus C. So how to describe B plus C? Again we have to looking at okay, because this is the initial point of B, and this is the ending point of the B. So and then we're going to add up this add up the B plus C. So this is the ending point. This is the ending point of this B, and then this is the starting point of the C. So we have to move this point to here, right? Okay, now let's move to this point. So since C is here, so this is the ending point. So this is the ending point. So we just move this. So basically, we just move this point to here, right? Equals to here. Okay, let's see. This items here, and then we can do it. The first one is to translate vector C to the vector B. Vector B. Okay, so translate vector C to the vector B. So from this initial point to the ending point, initial point to the terminal point, right? So now we have to move these two, right? So basically, from here we can see very clearly, okay, because these two things is the same thing, okay. So we can have A plus C equals to, then we will have the X component. So X component is what? X component is they have displacement is going upwards, okay. So they have a displacement for 1 unit. So they have 1 unit to 1 unit to the right. And 3 is Y component. So we have 1 unit going down, right? Downward. So we can have B plus C equals to 1 unit to right and 1 unit downwards minus 1. Okay. So in this case we have another answer. So we have final answer equals to 1 minus 1, right? Okay. Okay, let's talk about this. For this B plus C, so basically we also can use this parallelogram law for vectors. So we can use a different way. Okay, the different way is which way? The different way is we move this B to here. Okay, we move B to join up the initial point. So then from here we can use this parallelogram law of vector additions. Okay, let's assume how we do that. Okay, so basically we can translate B to C, the initial point. We can combine these two initial points. Okay, let's do differently. We're going to erase these things, okay? Erase the first one. Let me see how to use the parallelogram. Okay, so this method everyone knows, right? Okay, I'm going to remove this triangle way. Okay, now we're going to use another method. Okay, we join up these two initial points. Okay, we join up the initial point. We move this B to here. We join up initial point. Then from here, okay. So once when we translate this one to here, so now we're going to use the parallelogram law. Okay, once we translate this point to here, we're going to draw this thing. Okay, we're gonna remove this. We're gonna remove this b. Okay, because we already transferred it to here. Now, the next one. Okay, so we have this parallelogram. Now we join out. We know a plus b. We know the b plus c equals to the diagonal of this, right? So this is b plus c. Okay, so from here, so the first way, okay, use parallelogram law, okay, and then translate vector b to vector c. We join up the initial point. We have the common initial point. Remember what we studied in this parallelogram? Initial point. Both initial point joining up here is a common point here, right? So then from here we will know, okay, because this is the parallelogram. So b plus c equals to the diagonal of parallelogram. So from here we just find out, so what's happening from b plus c. So we'll apply the same concept. So the x component is, and find y component is. So x component is the 1 unit to the right, and x unit is 1 unit down. What? So from here we can work out, so the same result, 1 and minus 1, right? So in this case we use the parallelogram law to calculate what is it? B plus C, right? Okay. Okay, we find the answer. So now let's relook at this example 7. So when we find out, okay, so if I say we use the column vector to represent A and column vector to represent B, so that we see what's the result we're going to get. Okay, so let's say B, the A use the column vector, so we will get a result as is going to from this initial point to terminal point. So it is 1 unit to the right, 1 unit to the right, and then same time going downwards. Downwards is 1, 2, 3, 3 units minus 3. Okay, so and for the B, okay, so basically this is going downwards. So basically 2 unit, 1, 2, 2 unit, 2 units, 2 units to the right, so it's minus 2. And then same time we also have 2 units downwards from this initial point to this terminal point, so it's minus 2 downwards. So now we have the vector column for this A and B. Let's look at it the other way. Okay, same thing. Let's cut this cross. Okay, so since we have A equals to 1 minus 3, and then B equals to 2, 2. Okay, so now we take consideration of these things. Okay, let's consider it as the column matrix. So in the matrix, column matrix. Okay, so from here we can see that it's a 1, 3 plus 2, 2, then we will get a result as this. So we have 1 plus minus 2, 3 plus minus 2. Then we get a result. We get a result as minus 1 and minus 5. So from here we can see that x equals to a plus b. Right? So we can find out this answer. So, okay, if we use the same concept as C, okay, C we also can know what is the column of the C. Okay, so this is 1. Okay, so if we change the idea, we can find out the C as well. So what's the C? C. Let's say what's the C? And C equals to. So what's the answer of the C? C is the going upwards. So upwards is the. So basically it's 1 unit. So this 1, 2, 3, 3 unit to the right, and 1 unit going up. So it's 1. Okay, so from here we can see that. Okay, number 2. Since we're going to look for B and C, right? So we can find out the B equals to 2, 2, and C equals to 3, 1 as a column matrix. So we have minus 2 plus 3, 1. So equals to minus 2 plus 3 and minus 2 plus 1. So we have the answer is 1 minus 1. So this equals to B plus C, right? So, okay, now from here we know a very important concept. Okay, this is a very important concept. Okay, so in the column, in addition of the column vectors, so we just add up the x factor to x factor, and then x component to the okay, so here we know a very important concept is just to add x component to another vector's x component, and a y component plus another vector's y component. So please just add up x, y, y. So we get this thing. We can find out the same answer here. Okay, so this is now we're going to come out formula for this. Okay, this is very clear, right? Okay, let's move on. Now we're going to get a very important concept here. Okay, so in generally, so addition of column vectors can be done by adding up their x factor to x factor in this case. Okay, so for example, x a y a plus x b y b. So we can get the component as this: x a plus x b and the y a plus y b. So they are x component plus x component each other, and y component plus y component each other. Okay, this is very important. Okay, so basically today we have talked about this 3 very important concepts. The first one is the triangle law of the vector additions and the parallelogram law of the vector additions. Then we discuss for the example 7. So when you go back home, please try it for 7. Because 7 is similar to this example 7, so you try to find out whether you can get the correct answer for try 7. And on top of this, so from example 7, so we also come up with a very important concept of this. So basically, column vectors can be added up each other by adding up their x component plus x component, the y component plus the y component. So we can get the same result. If we can get the same result if we as the triangle law or parallelogram law. Okay. Thank you very much for today's watching. Thank you. I'll see you in the next video. Bye bye.